Alrighty, we're looking here at Chapter 6, Section 1, Exercises. We're going to take a look at the first few. They're all about perpendicular bisectors. And the thing we need to remember about perpendicular bisectors is, hold on here. Okay, there we go. The thing we need to remember about perpendicular bisectors is every point on the perpendicular bisector of a segment is exactly the same distance from each end of the segment. So first, these exercises are going to kind of work two different ways. In this example here, we see that HK is a perpendicular bisector, and we know this because, first of all, we see that it's got that right angle symbol there, so it's perpendicular, and because the distance from K to G and K to J are the same distance. So by definition, this is perpendicular, and it bisects the segment, cuts it in half. Because we know it's a perpendicular bisector, we can conclude that every point on it is the same distance from J as it is from H, from G, including point H right here. So H is the same distance from J as it is from G. And we know this because H is a perpendicular bisector. Next, exercise 2. This one works the other way around. We can see that point T is the same distance from Q as T is from S, because we got the measurements here. We also see that TR is perpendicular to QS, with the marking here. Now, because RT or TR is perpendicular to QS, and because point T is the same distance from Q as it is from S, we know that TR is a perpendicular bisector of the segment. And because we know it's a bisector, we know that it cuts QS right in half, so the distance from R to S is the same as it is from R to Q. Next, exercise 3, same deal here. We see that the markings here, the two tick marks, tell us that D is the same distance from C as D is from A. We also see from the right angle marking here that DB is perpendicular to AC. Therefore, DB is a perpendicular bisector of AC. So we're going to set up an equation. We know that AB is equal to BC. So we're going to set up an equation that reflects that. 5x equals 4x plus 3. We'll have to solve for x, and then we will substitute that value for x back into the expression for AB to figure out what that length is. All right, next up, exercise 4, same deal. We see that XU is a perpendicular bisector of VW, and we know this because the markings tell us that the distance from V to D is the same as the distance from D to W, so that means it's a bisector, and the little right angle symbol here tells us that it's perpendicular, so perpendicular bisector. Because of that, we know that point U, or any other point, including X for that matter, but any point on that perpendicular bisector is going to be the same distance from W as it is from V. So we know that 7x plus 13 is the same as or equal to 9x plus 1. So we set up our equation, 9x plus 1 equals 7x plus 13. Well, to solve that equation, don't forget you have to go back and substitute that value for x back into the expression for UW, which is 7x plus 13, to get a length there. Right? Good luck.